Hi everyone, this is Manas, your friend and tutor, and in today's video we are going to apply the I-center method to find the velocity of RAM in a Whitworth quick return mechanism. As far as the dimensions of all these links, all these paths are concerned, well, you can check them out from over here, red color, right? You first need to have a plain sheet of paper, a pencil, a compass, a protractor. With all these tools, you have to recreate this figure on a plain sheet of paper, and no scale is required. Draw this to full scale. That is my recommendation. And if you don't think this would fit in to your drawing sheet properly, then you can definitely manage with a scale of, let's say, 1:10. This will do the job. Then in that case 200 will become 20, 350 will become 35. Well, this would be appropriate, isn't it? Otherwise 200 mm and 350 mm, this would become very big. I did this initially on AutoCAD, therefore I do not need any sort of scale. Okay, I drew this with full scale. Anyways, my recommendation to you would be to use a scale of 1:10. All the dimensions would be divided by 10, and with those new dimensions you have to recreate this figure. Now comes the most important part. Find the velocity of the RAM. This is the RAM. Okay, and this OP link is actually rotating, right? And this link RB is absolutely straight, and it is also rotating sort of, okay, or oscillating, you can say. And then this link P rather, or slider P is sliding along this RB only. Okay, now the crank is making an angle of 120 degree with the fixed link. This over here OA is the fixed link, and the crank, that is OP, is making an angle of 120 degrees. Okay, this has been given to us. Let me erase this right now. And this, by the way, is rotating with a speed of 10 radians per second. The first thing which you need to do is to name all the parts, name all the elements, name all the links. We are going to start off with the fixed link. Let's say this is 1. This is 1. This is also going to be 1. Okay, don't worry. Secondly, this crank, let's mark it by 2. Then this slider, let's mark it by 3. Then this link, RB link, let's mark it by 4. Then this one, let's mark it by 5. And this RAM over here, let's say this is 6. Done. So marking is over. Now what? Now you first need to identify which I center is supposed to be calculated, because in totality the number of links are 6. If you just try to apply this formula, n is equal to n minus 1 over 2, you shall realize that the number of I centers work out as 15, because 6 multiplied by 6 minus 1 by 2 will give you 15. So you don't have to precisely locate each and every I center. Okay, the only I center which is required to make the calculation is something that we are looking forward to. And please take a look at this. Find the velocity of the RAM. So velocity of RAM has been represented by 6. Okay, RAM has been represented by 6. And what has been given to us? We've been given the angular velocity of link 2. So what we've been given is 2. What we need to find is 6. That clearly means that we need to find the location of I center 2, 6. So your prime objective right now is to precisely locate I center 2, 6. And for that, all the construction we would be doing. How to approach? First of all, you need to follow the circle method. Draw a circle. Make 6 points, randomly 6 points. Okay, it does not precisely have to be an exact hexagon. You can make this. You can even discard this circle. You can straight away make a hexagon. Okay, 1, 2, 3, 4, and so on. It's your wish. I like to do things in an organized manner. That's why I did this. Anyway, and my recommendation to you would be to make this on AutoCAD. Do this on AutoCAD. Okay, I strongly recommend this. If not on AutoCAD, then definitely on a plain sheet of paper. Okay, so 1, 2, 3, 4, 5, 6, all of them have been marked. The first thing to do is to mark all the I centers which are fixed as well as permanent. Once that is done, then we'll follow it up by locating I centers which are neither fixed nor permanent. Okay, let's start with I centers which are fixed and permanent. So let's start from here. 1, 2. This is link 1, this is link 2. That's a fixed I center, that is 1, 2. I center 1, 2. Blue color, always remember. The links have been represented by red color. The I centers will be represented by blue color. 1, 2. This is 2. Okay, this is crank, and then this slider over here, sliding above or along this RB. Anyway, this is the slider 3. and this is link 2, and therefore this over here, this very small dot, if I can make this is 2 3. Where are we going? Yeah, this is 2 3. Now this 3 4, so that's 1 2 is over, 2 3 is also over. What about 3 4? So take a careful look. This is sliding in this fashion, in this direction. Now for this position of the crank, right now, that is 120 degrees, this is sliding in this manner. Okay, and when it is sliding in this manner, in this direction, its eye center will be perpendicular in this way. That is I34 will be at infinity. Done. I34, mark it. Then as far as I45 is concerned, it's very simple. You can mark it very easily. I45, that's 4 and that's 5, that is I45. And then I56, let me mark it 4 5. Then I56 is right here. This is link 5 and this is the RAM or the slider, you can say. This is 5 6. And what else? 5 6 done. What about 1 6 and 1 4? Okay, let me mark 1 4 first. So this is link 1 and this is link 4. So this is 1 4, 1 4 done. 1 6. So this fixed over here is actually link 1. Okay, and link 6, that is the RAM or the slider, is sliding in this fashion, in a horizontal fashion. Therefore the eye center will be in a direction perpendicular, this direction. I16 will be perpendicular somewhere at infinity. So all the eye centers have been precisely located, which were fixed and permanent. Now we need to work out something else. Okay, so what we need is eye center 26. Eye center 26. Is there a method? Is there a procedure which will help us find this eye center, locate this eye center? Yes, there is. Okay, it's a bit of a hit and trial approach. So we want I26, simply I26. Now this 2 6, when you join 2 with 6, you have a line. That line should be a part of 2 triangles. One triangle is over here, 1 2 and 1 6, but the other triangle is nowhere to be seen. So how can that be approached? The other triangle could be this one and this one. Okay, so if you want to find eye center 2 6, you first need to locate eye center 4 6 and eye center 2 4. Then only you can approach. That means in order to get to 2 6, you need to find eye centers 2 4 and eye centers 4 6. So our objective now has shifted. We first were looking forward to calculate or rather locate 2 6. Now we know in order to calculate or locate 2 6, you need to find 2 4 and 4 6. So let me rub this and let's begin our journey. Okay, 2 4 and 4 6. What shall I locate first? Let's say we start off with 2 4. Okay, we want this eye center 2 4. So 2 4 is a part of triangle 2 3 4 and also a part of triangle 2 1 4. 2 4 is a side which is being shared by two triangles 2 3 4 and triangle 2 1 4, isn't it? So 2 3, make a line joining 2 3 with 3 4. Make a line joining 2 3 and 3 4. Where is 2 3? 2 3 and 3 4. Make a line. So this is the line. You don't have to make it. It has already been made. Okay. Then what you need to do is make a line joining 1 2 and 1 4. 1 2 and 1 4. 1 2 and 1 4. Okay. Produce it. These two intersect somewhere here and that's the eye center 2 4. That's the eye center 2 4. So we have now successfully located eye center 2 4. What we need now is eye center 4 6. Let's start. 4 6. Here we go. Now 4 6 side, this can be clearly assumed as a part of triangle 6 5 4 and also a part of triangle 4 1 6, isn't it? Once again, 4 6 is the eye center which we now need to locate, and it is clearly a part of triangle 4 5 4 as well as of triangle 4 1 6. So draw a line connecting eye centers 5 6 and 4 5. 5 6 and 4 5. Here we go. 5 6 and 4 5. Just produce this. Okay, you can also produce this in this direction also, but that's not needed, so don't worry. Once again, 4 6 is a part of triangle 4 5 and 4 6. 4 5 and 4 6. Not 4 6 but 5 6. 4 5 and 5 6. Make a line. Okay, this much portion has already been made as it's a link. Just produce it. Then apart from that, it is also this 4 6 is also a part of 1 6 and 1 4. So where is 1 6? Where is 1 6? 1 6 is in a vertical, and where is 1 4? This is 1 4. So 1 6 is in the vertical. So just make a vertical line passing through 1 4. 1 6 is at infinity, by the way. Okay, you cannot find it. So just make a vertical line through 1 4, and these two are intersecting somewhere here, and this is going to give you your eye center 4 6. That's it. So eye center 4 6 also has been located. Now things would become very easy. Now make this. Okay, let's start. So this 2 6, we wanted the eye center 2 6, isn't it? And 2 6 is actually shared by triangles 1 2 6 and triangle 6 4 2, isn't it? So draw a line connecting eye centers 1 2 and 1 6. 1 2 and 1 6. 1 6 are at infinity, so this is the line. This is the line I am talking about. This is the vertical line. 1 2 and 1 6. Done. That's done. These two are over. Then let's try to work this out. 2 4 and 4 6. 2 4 and 4 6. So where is 2 4? Here it is 2 4. Where is 4 6? Here it is. Man, this is weird, isn't it? 2 4 and 4 6 are overlapping. Look, if you connect 2 4 eye center 2 4 with 4 6, if you connect eye center 2 4 with 4 6, you have this line. Okay, now let me use a different color. Better to use a red color. Okay, then we also had this 1 2 and 1 6. This is 1 2 and 1 6 is vertical at infinity. That means it is going to be this line. So what actually is happening is, when we connect those dots via these two pieces also, then those two lines are overlapping, and when lines overlap, you have infinite points. We want just one single point. We want one intersection point. So this method is not working. Something else has to be worked out. So let me erase all these stuff. This is not working. Something else has to be worked out. Some other eye centers might have to be calculated or located. So how to approach? Well, that is going to be very interesting. Okay, so we obviously need to reach eye center 2 6, and for that some other things have to be worked out. Let's connect this like this. Okay, so 1 2 and 1 6, done. But this has to be shared by one more triangle. Let's say this is that triangle 2 5 6. So if we can somehow find or locate eye center 2 5, then our job will become very easy, because 2 5 and 5 6 make a pair, and 1 2 and 1 6 make a pair, right? So our objective now has shifted from 2 6 to 2 5. So how to find 2 5? That is also a bit complicated. So let me just rub these two. We are going to kick off first of all by calculating this eye center I 5 1 5. Okay, do watch this carefully. 1 5 1 5 1 5, because once you find this eye center 1 5, 2 5 can be found very easily. Just try to work it out. It's a sort of hit and trial approach. Just try to think, pause the video and think about this. I am pretty much sure that you can find the reason why. 1 5 is shared by 1 6 5 and also 1 4 5. 1 6 1 5. Connect a line between 1 6 1 5. Here we go. 1 6 1 5. 1 6. This is 1 6. Where is 1 5 1 5? Not 1 5 but 5 6. 1 6 and 5 6. So this is 5 6 and 1 6 is at infinity. So this is the line joining 1 6 and 5 6. Then we have this 1 4 and 5 4 or 4 5. 4 5 and 1 4. 4 5 and 1 4. Produce intersection. This is going to give you eye center 1 5. Once I 1 5 is known, okay, this is going to get very easy. Connect 2 with 5. So for 2 5, just listen to this very carefully. Okay, for 2 5. 2 5 is a side shared by triangle 1 2 5, isn't it? 1 2 1 5 and also 5 4 2. So again, let's start again. 2 5. So 2 5 is a side shared by triangle 1 2 5 and triangle 2 4 5. So this is triangle 1 2 5. That means 1 2 and 1 5. 1 5 already has been marked, and this is 1 2. Join a line connecting 1 5 with 1 2. Here we go. Okay, so this is done. This is done. This is left and this is left. So now connect eye centers 4 5 with 2 4. Where is 4 5? This is 4 5. Where is 2 4? This is 2 4. So make a line connecting 4 5 with 2 4. Here we go. 4 5 with 2 4, and these two intersect somewhere here, and this is what we really wanted. Okay, and that's your eye center. Eye center what? Eye center 2 5. That's known to us. Now let me but rub the stuff. So that's done. That's done. Now we have a different approach. Okay, so we've successfully located eye center 2 5. Okay, now we want 2, 6. Here we go. Connect 2 with 6. This is initially what we wanted. 2, 6. 1, 2, 1, 6. Part of triangle this way. This side is being shared by 2 triangles. One is this one. 2, 1, 6. Also shared by 2, 5, 6. So 1, 2 and 1, 6. Where is 1, 2 and 1, 6? This is 1, 6. Where is 1, 2? This is 1, 2. So this is the line I am talking about. So 1, 2 and 1, 6 is this line only. 1, 2 and 1, 6 is this line only. So somewhere along this line you are going to have this eye center, that is 2, 6. Then we have this 2, 5 and 5, 6. Where is 2, 5? That's 2, 5. Where is 5, 6? That's 5, 6. So start a line from 5, 6 connecting 2, 5 and then extend. These two intersect somewhere here. That's eye center 2, 6. Done. Eye center is now known to us. Okay. Once eye center is known, things would become very easy. Now let me tell you what the idea is. So the idea is eye center 2, 6 can be assumed both on link 2 and also link 6. You can assume this eye center to be a part of link 2 as well as a part of link 6, and they can obviously make the calculations very easy. How to approach? Let's say we are assuming initially that eye center 2, 6 is on link 2, and let's start making the calculations. In that case, the velocity of eye center v26 is going to be equal to omega 2. This is going to be omega 2, by the way. Let's say this is in the clockwise sense. Okay, this is omega 2. Omega 2 multiplied by. So it's something like this. Let's say this is the disk and it is rotating about this eye center 1, 2. 1 second. Let me do this properly. This 1, 2 over here. That's 1, 2. And above 1, 2 we have got this 2, 6. This is the radial distance. This is the what you call the center of rotation, and the rotation is in the clockwise sense. So this is going to be, this is omega 2, omega into this is what? This is r. R means the distance between eye centers 2, 6 and 1, 2. So 2, 6 minus 1, 2. Once you know the value of 2, 6, once you know the distance between 2, 6 and 1, 2, you can put it up and calculate the value of V26. It's very simple. Okay. Now let me show you on AutoCAD what that value has worked out as. Let me show you. So guys, if you watch carefully, the distance between 1, 2 to 2, 6 has worked out as 141.31. Let me show that dimension again to you. Between 2, 6 and 1, 2, this is 141.31. So this is a very accurate value. You won't be getting this value on if you try to make this, attempt this on a plain sheet of paper. But if you do so on a machine, on AutoCAD, you are definitely going to have the same value as I have achieved. Okay, so that's 141.31. So I would assume it as 0.141 meters. By the way, this is 141.31 millimeters. So when you do the conversion, it's 0.141 meters. That's it. Let's get back to PowerPoint and let me show you how this can be accomplished. So if you watch carefully, this omega 2 has already been given to us. This is 10 radians per second, and this distance in meters has to be taken as 0.141. So this is fairly simple. This is going to be equal to 1.41. Velocity obviously is in meters per second. Now this sort of is undergoing a clockwise rotation. If that is so, then this would be somewhere along this direction. Okay, this is velocity 26. Now, but we are not supposed to find the velocity of the eye center 26. What we are supposed to find is the velocity of the RAM. So if this is moving in the clockwise sense, this also will be moving in this direction towards the right hand side. So what now you need to do is, you need to assume, let me draw it over here, assume what? Assume eye center 26 on link 6. On link 6. When you do that, make sure that the link 6 is extremely big, like this. This is link 6, and here we have 2, 6, and we know the direction of 2, 6. It is somewhere along this direction, V26. So all the particles on this RAM, on this slider, are going to have the same velocity as this eye center V26. That's why the velocity of ram is going to be equal to the velocity of the eye center, which ultimately worked out as 1.41 meter per second. It's that simple. This is how you need to approach all the problems based on eye center method. It's a bit long, and the construction also is it's a bit cumbersome. I can completely understand. That's why you need to select which method to follow. But that also depends on your examination. Sometimes they might ask you to solve a particular configuration using eye center method only, and maybe sometimes you will be asked to solve a particular problem using the relative velocity method. Completely depends on what the scenario is. Anyway, my objective is to clearly and very simply explain you all the methods with beautiful animations. I hope you like this video, and we're gonna meet in the next video with some problems based on acceleration diagrams, and also take up the Coriolis component of acceleration. All of that and much more coming up in the next videos. Until then, take care, have a nice day, keep learning, keep watching, and thank you.